Good evening, Cardinals. It's me, Mr. Ernst, and today we are going to be talking about complex numbers and what complex numbers actually are. And to start this off, I want you to take a look at this graph here. This graph is x squared plus 4x plus 5, and I want you to take a look at what might be a little bit weird about it. What's wrong with this graph that we really haven't dealt with before? Any ideas? If you figured it out, if you haven't figured it out, let me give you a clue. Most of our graphs look something like, most of our graphs look something like this, right? Parabola. Both of these are parabolas. Mine's a little bit shakier. Not a big deal. The key factor that I want to point out to you, though, is that the purple graph is crossing the x-axis. That's where our answers come from. Every time I ask you to solve a quadratic equation, you give me two x answers, and those two x answers are here and here. So for example, this x value might be, looks like it's maybe negative, it's close enough, we'll round it, -4, and this one's close enough, we'll say 0. You usually have two x answers because there are two places it crosses over the x-axis. However, this tricky blue parabola is not crossing my x-axis at all. So what is x going to be equal to? What are my two x answers? To answer this, we have to consider imaginary numbers. When we're looking at something, when we're looking at imaginary numbers, this is just another thing that kind of falls under number theory. We've talked about a couple of things. First off, you were introduced to positive numbers. There are 5 apples. After that, you were introduced to negative numbers. There are negative numbers on that side. You're also introduced to partial numbers, something like 1/5. And then this year, we've also talked about irrational numbers, something like the square root of 5. That's going to give you some infinitely repeating decimal into oblivion. So we've talked about regular positive numbers, negative numbers, partial numbers, rational and irrational numbers. And today we're going to be talking about imaginary numbers, represented by the letter I. So I always like to think of the SpongeBob meme, imagination. He's got the little hands. There we go. Anyways, as I get distracted, let's talk about imaginary numbers for a minute. Imaginary numbers are based off of exponents. For example, if I have 3 squared and -3 squared. Cool? 3 times 3 is going to give me 9. -3 times -3 is still going to give me +9. So the square root of 9 is equal to 3, and the square root of 9 is also equal to -3. But what about the square root of -9? What the heck does that equal? What number, when multiplied by itself, is going to give me a -9? Well, the easy answer to that is that there really isn't any number that that's going to work for. There's no two numbers that I can multiply together. I could do 3 and -3, but then those aren't the square root of 9 because they have to be the same number. So this is where I comes into place. I is an imaginary number. I is an imaginary number that is represents the square root of -1. And it is how we can find the square root of -9. Because now when we have the square root of -9, we can now break, and I need a little bit more room, didn't get myself room. I can now break the square root of -9 into 2 pieces. Instead of just being -9, I can break this into the square root of -1 and break this into the square root of 9 because -1 times 9 gives me -9, so I can break these into 2 different parts, multiply these together. And what this is saying now is I can do square root of -1 gives me I, and the square root of 9 gives me 3. So the square root of -9 gives me 3i. Cool? So I allows us to find the square root of negative numbers, something that we weren't able to do before. But now I can be used to find the square root of negative numbers. The square root of negative 9 is 3i. The square root of negative 25 would be 5i. And just for funsies, the square root of negative 81 would be 9 times I. Cool? Okay, so now that we've talked about what negative numbers are, or I'm sorry, imaginary numbers, I hope you guys know what negative numbers are. Now we can actually get to some of the problems. We're going to go through a couple of the problems on the assignment together. I would highly, highly, highly recommend that you go through and attempt those problems on your own first. See if you can do them on your own. Take a look at A1, which looks an awful lot like this. Take a look at A1 by yourself, see if you can solve it, and if not, come back to this video or unpause the video, and then I will walk you through it with you, okay? I am personally going to be going over A1 and A3, and then a couple problems on, I think it's D? Is it D? Yes, D. But I'm going to do A1 first. So A1 says explain why 2i squared is equal to negative 4. So I need to prove that 2i squared is equal to negative 4. So 2i is the square root of negative 4. Sure, okay, whatever. So let's take a look. 2 times I squared is equal to negative 4. Now, what I said on the previous page was that I, right here, is essentially the square root of negative 1. So I can rewrite this as 2 times the square root of negative 1. Squared is equal to negative 4. Cool? From here, we have this exponent on the outside, which means we have to essentially have two sets of these being multiplied. So I'm going to continue it up over here. So I have 2 times multiplied by the square root of negative 1. That's my first one, but I have 2 of them. So I've got to write it again. 2 multiplied by the square root of negative 1. So 2, that's my first, this is like my first set, and that's my second set. So we've got the square now. Cool? And all of this is still equal to negative 4. So let's see, as we go through this, I have 2 multiplied by 2, that gives me 4. And now I have the square root of negative 1 times the square root of negative 1. Now I want you to think about this, because if we have the square root of negative 1 squared, because it's times itself, remember these guys are going to cancel out. The 2 and the square root are going to cancel out, leaving me with just 1. So we have, just negative 1. It's still a negative 1. So we have 4. 2 times 2 gives me the 4. Square root of negative 1 times the square root of negative 1 gives me negative 1 is equal to negative 4. 4 multiplied by negative 1 gives me negative 4. And negative 4 is definitely equal to negative 4. So we have explained why 2i squared is equal to negative 4, because I got this answer right here. Cool? In other words, 2i is the square root of negative 4. If I was to take the square root of negative 4, I would get 2i. Cool? That is the first one. I'm going to go through and do the second part of this now. Once again, if you have not done 3 yet, I would highly recommend trying to do 3 on your own first, and then unpause the video, and I will help kind of walk you through the problem. 2 is solved the exact same as 1, and 4 is solved the exact same as 3. So I'm not going to do those ones, because I do want you guys to try some of these on your own. Get a little bit fancy with the imaginary numbers. A3 says, use I to write the square root of negative 49 as a complex number. Cool? And a complex number just means a number that is going to involve the number I. So this is kind of what we were looking at beforehand. I told you guys that. The square root of, negative 9 was 3i. The square root of negative 25 was 5i, and so on and so forth. And again, the reason for this, let me go back over that real quick. The reason for this is because you can split this up into two different things that are being multiplied. I can split negative 25 into negative 25 and, I'm sorry, positive 25 and negative 1, because 25 times negative 1 is equal to negative 25. We keep the square roots on both of them. Square root of 25 simply comes out to 5, and then the square root of negative 1, as we've talked about a few times, square root of negative 1 is equal to I. So this is just 5 times I, or 5i. So once again, when it asks us the square root of 49, square root of negative 49, this splits once again into two separate parts. We have our positive 49 multiplied by negative 1. We have square roots on both of these, so we're basically splitting negative 49 into 49 and negative 1. Square root of 49 comes out to simply be 7. The square root of negative 1 comes out to be I, imagination. 7 multiplied by I gives us simply 7i. And that would be our answer for that question. Cool? Just so that you guys are aware, because we can't really fathom the idea of the square root of negative 1, we use I as kind of a placeholder. So it's basically telling, when you give an answer like this, it's telling the math community, it's telling your math teacher, it's telling other students, it's telling them, hey, I'm working with some really weird theoretical numbers here. I can't count out the square root of negative 1 apples, but I know that I need this to be able to solve a problem. Because just like in that original thing, the original problem I showed you earlier, we know this parabola does exist, but we also know this parabola does not hit the x-axis. So I is what allows us to basically work in this almost near impossible world. It's where a lot of theoretical stuff starts to come in, and it's pretty neat. All right, so that is that. Let's move on to problem D now. So that was all of A. So the answer to A3 was 7i. Boop, boop. Let's move on to question D now. Get rid of this graph. There we go. Once again, I'm just going to be answering, for this one, I'm just going to be doing one of them. D1. Cool? This one is simply doing what we did on the last assignment. We're going to use the quadratic formula to solve these equations. Write your answers as complex numbers in the form a plus bi. Again, the reason we're talking about imaginary numbers is because the quadratic formula is infamous for making imaginary numbers, and you're going to see why as we start to make this. So we have x squared plus 2x plus 2 is equal to that. Let me get my Pythagorean. Let me get my quadratic equation, or my quadratic formula going here. It is going to be negative, let me see, get my colors going, negative b plus or minus the square root of b squared minus 4ac all over 2a. And just like before, I'm going to simply replace, this is my a value here, my b value here, and lastly, my c value. So I'm going to start off by replacing a. A is a 1. Remember, it keeps it as an invisible 1. So long as there's an x squared there, we know it's a 1. So any a value is going to be 1. So, whoa, that's way too big. This a value is 1. And this a value is 1. My next value is b, is 2. Any b is going to be a 2. So this becomes negative, that becomes negative 2, and this becomes 2. Last one is simply going to be c, which is a 2. Cool? So let's go through and kind of start simplifying some of these terms here as I go through. Starting off with my 4, I have 4 times 1 times 2. 4 times 1 is 4. 4 times 2 is 8. So my first number here is 8. There we go. Next one, I have 2 power of 2. simplified gives me simply 4. And then down on the bottom, we have 2 multiplied by 1, which is going to simply give me 2. Cool? Now on the inside of these, here it comes. Here's where the imaginary number comes in. We have 4 minus 8. 4 minus 8, for those of you playing at home, gives me -4. I'm left with -4, which means I am now trying to take the square root of a negative number, which is exactly why we need imaginary numbers, because I can't solve this without it, okay? So I have simplified this as much as possible. Move this over here. Real quick, I'm going to put over on the side here, we know that we have the square root of -4. Again, this is going to split into 2 separate parts. We have the square root of a +4, and we have the square root of -1. Square root of +4 simply gives me 2. Square root of -1 is going to give me I. So the square root of -4 is simply 2 times I. So my last simplification is I can take this thing out, and this is going to be 2I. Get rid of all this. Once again, because we have this, the plus or minus sign, that means that there's actually 2 different equations here. So I'm literally just going to copy and paste this over. We have 2 different equations here. Copy, paste. I'll do it like this. So my first one we'll say is, going to be the adding, and the second one will be my subtraction. Cool? So -2 plus 2i and -2 minus 2i, both of them being divided by 2 afterwards. Cool? So now while I can't do -2 plus this. Both of these are going to be divided by 2. This actually makes life very easy for me. -2 divided by 2 gives me -1. 2i divided by 2 simply gives me I. On this side, -2 divided by 2 simply gives me -1 minus 2i divided by 2 gives me I. And those are my 2 answers. So I say x is equal to -1 plus I and -1 minus I. Ba-bum. And there's my answer in the form a plus bi. This is my a. This is, the b is a 1 because there's nothing in front of the I right now. And then that's my I. So it is all set. That's my final answer. X is equal to -1 plus I and -1 plus -I. Again, if we were to graph this out on an actual thing, this equation would cross at 2. It's got a y-intercept of 2, but it's not going to actually cross the y-axis at all. So these are 2 imaginary numbers. Who knows where they're actually kind of crossing up here? Cool? And that's how you go through it. So each one of these, put them into the quadratic formula, and just remember, instead of leaving it as a square root, now you're going to be converting them into 2 i's, because they should all be giving you negative numbers from there, okay? If you guys have any questions, please feel free to reach out. This was one of my longer videos because, well, this is kind of a weird problem to look at. So, again, if you guys have any questions, please feel free to reach out. Have a great rest of your night. Later days.